We're looking at page 21 in the practice problems. So here's the first one. We have somebody on skates with a jetpack. And in this case, the jetpack is powering a 25 kilogram person. And she's accelerating forward. Right. Our formula is that acceleration is equal to force divided by mass. All right, that's Newton's second law. That is the relationship that we know. So in this case, if the force, which is the amount that the rocket is pushing her backwards, if that changes, what is our acceleration? Well, when the rocket pushes back at 100 newtons, then our acceleration is a force of 100 divided by 100 newtons divided by, what's our mass? 25 kilograms equals 4 meters per second squared. And if our force is 200 newtons, then we take 200 newtons divided by 25 kilograms, and our force is our acceleration is 8 meters per second squared. What about the other way around? What if our acceleration is 10 meters per second squared? What does that tell us about the force? Well, force is equal to mass times acceleration. And so if we've got, we have an acceleration of 10 meters squared times a mass of 25 kilograms, because that's what our skater is, then our force is 250 newtons. All right. Let's do it again, except this time we'll make our skater be 50 newtons. So we've got, or the weight of our skater is 50 newtons. So if the force is 50 newtons and she weighs 50 newtons, the acceleration is 0. There's nothing, her forces are balanced. In that case, we've got 50 newtons, a force of 50 newtons going forward, and a force of 50 newtons going backwards. The summation of forces is equal to 0. There's no acceleration. What if our force is 100 newtons? Our formula is that acceleration is force divided by mass, 100 newtons divided by 50 kilograms. So our acceleration is 2 meters per second squared. And if our acceleration is, or if our force is 200 newtons, we have 200 newtons divided by 50 kilograms equaling 6 meters per second squared.